Access Control System. Introduction. An airport access control system is a security system used to manage access to different areas within an airport facility. It ensures that only authorized personnel can access restricted areas such as the airside, where aircraft are parked and serviced, and the terminal buildings, where passengers are processed and checked in. The system typically involves the use of identification technologies such as biometric scanners, smart cards, or PINs, which are used to verify the identity of individuals seeking access to restricted areas. The access control system then grants or denies access based on the individual's authorization level, as defined by the airport's security policies. The system is usually integrated with other security technologies, such as CCTV cameras and intrusion detection systems, to provide a comprehensive security solution. The goal of the access control system is to ensure the safety of passengers, airport employees, and aircraft, as well as to prevent unauthorized access, theft, or sabotage. The Access Control System, ACS, in an airport environment provides access control and identification for all personnel in an airport site. The ACS system normally forms part of, and in many cases is the integration platform of the airport security system. The ACS provides the access controllers for all landside to airside entry points within the terminal building and at the gatehouses along the perimeter fence, as well as controlled entry into other secure rooms such as telecom and operation rooms. The ACS system contains a complete database of all cardholders and also provides the badging system for the management and issuing of cards, which is integrated into the ACS database. The ACS system will be integrated with the fire alarm system, FAS, to provide emergency egress for staff and passengers, and lifts to provide controlled access to airside floors. The ACS system may also be integrated into the Airport Facility Management System, FMS, and more as listed below. Components. Access control systems typically consist of several components, including Access Control Panel. The Access Control Panel is the central processing unit of the access control system. It receives and processes inputs from the various access control devices, such as card readers, biometric scanners, or keypads, and sends output signals to the locking mechanism to either grant or deny access. Access Control Reader. The Access Control Reader is the device that captures the credential presented by the user to gain access. There are different types of access control readers, including card readers, biometric readers, such as fingerprint or facial recognition, and keypads. Access Control Credentials. Access control credentials are the physical or digital tokens that identify the user and grant access to the system. Examples of access control credentials include key fobs, smart cards, and PINs. Locking mechanism. The locking mechanism is the physical device that secures the door or entry point to be controlled. It receives signals from the access control panel to either unlock or lock the door. Access control software. The access control software is the program that manages the entire access control system. It can perform functions such as adding or deleting user credentials, setting access levels, and monitoring system activity. Alarm system. Some access control systems include an alarm system that alerts security personnel if unauthorized access is attempted, or if a door is left open for an extended period. Monitoring system. The monitoring system allows administrators to monitor the access control system and track system activity, such as when users enter and exit the building. Engineering. An airport access control system, ACS, is a critical component of airport security infrastructure. The engineering parameters of an ACS are important considerations to ensure its effectiveness and efficiency. Here are some of the key engineering parameters for an ACS. Access points. Determine the number and location of access points where users can enter or exit the airport facility. Identification and authentication. Choose the most suitable technologies for identifying and authenticating individuals, such as biometric scanners, smart cards, or PIN codes. Access control policies. Develop access control policies that define who is authorized to enter or exit certain areas of the airport facility and under what circumstances. Monitoring and logging. Ensure that the ACS logs all access attempts and system activities for audit and forensic purposes. Integration with other systems. Ensure that the ACS integrates with other security systems such as video surveillance, intrusion detection, and fire alarm systems to create a comprehensive security solution. Redundancy and failover. Design the ACS to have redundancy and failover mechanisms to ensure system availability in case of hardware or software failures. Scalability. Design the ACS to be scalable to accommodate future growth and changes to the airport facility. Compliance. Ensure that the ACS complies with applicable regulatory and industry standards, such as the Transportation Security Administration, TSA guidelines, or the International Civil Aviation Organization, ICAO standards. Maintenance and support. Plan for ongoing maintenance and support of the ACS to ensure its continued effectiveness and reliability. Overall, the engineering parameters for an airport access control system must be carefully planned and implemented to ensure the security of the airport facility and the safety of its passengers, staff, and visitors. Thanks for watching.